This is a question from IPM Indore paper 2023 QA section. So here the first line is the general definition of greatest integer function where box x denotes the greatest integer not exceeding x, and this is called fractional part of x. So fractional part of x is equal to x minus greatest integer of x. So fractional part of x is x minus greatest integer of x. This is the general definition of fractional part function. So there is nothing new that has been provided in this question. So let's move to the second line. If n is a natural number, then the sum of all values of x satisfying this equation. Okay. So we need to use this equation to get some values of x, and then we need to add all those values to get to the answer. So the equation given is 2 box x. Box x means greatest integer function x plus n times fractional part of x. Now n is a natural number that's given, and fractional part of x is also provided. So I can simply replace fractional part of x with the given value, that is x minus box x. So 2 box x is equal to x plus nx minus n box x. This goes to this side. So we'll get n plus 2, n plus 2 box x, that is equal to n plus 1 x. So from here we can say x will be equal to box x times n plus 2 upon n plus 1. So this is how the x is. Now we need to find the values of x which satisfy this equation. And then we need to add all those values. Sum of all values of x that satisfy the given equation. Fine. So let us check for the largest value of x. If I replace x is n plus 1, where n is a natural number, so n plus 1 is also a natural number. So if x is n plus 1, then box x will also be n plus 1, because n plus 1 is a natural number or an integer. So box x will also be an integer. So in that case, x will be n plus 1 times n plus 2 upon n plus 1. So x is n plus 2. So we have assumed x as n plus 1, but from the equation we get x is n plus 2. So that is wrong. That means x cannot be equal to or more than n plus 1. So x needs to be less than n plus 1. Okay. So x has to be less than n plus 1. So that is the upper limit of x. Let us now check x for negative numbers. So if I put x equal to minus 0.5, in that case, box x will be minus 1. So minus 1 is less than minus 0.5, but quantity 1 is more than 0.5. And n plus 2 by n plus 1, that is also more than 1. So x equal to box x n plus 2 by n plus 1. This can never be true if x is negative, because this quantity, this absolute quantity is more than x, and this quantity is also more than x. So product of two quantities which are already more than 1, we cannot get that equal to x. So we can say x cannot be less than 0 also. So x has to be more than or equal to 0. So that that is the values of x that satisfy the equation. These are the values of x that satisfy the equation. Now we can think and add these values. So if I add these values starting from 0 to n plus 1, So we'll get, if I put x which is from 0 to 1, box x will be 0. So 0. If I put x which is from 1 to 2, if x is from 1 to 2, box x will be 1. So 1. And similarly, if x is from 2 to 3, then box x will be 2. So 2 and so on. When x is from n to n plus 1, box x will be n. So last number will be n. And then we have n plus 2 upon n plus 1, that is in multiplication to every number. So n plus 2 upon n plus 1 will be multiplied in common. So addition of these. So this is the addition of 1 to n. So the addition of all natural numbers from 1 to n is n into n plus 1 by 2. And with this, we have n plus 2 upon n plus 1 in multiplication already. So n plus 1 gets cancelled. So what we get is n into n plus 2 by 2. That is the required sum. So that's the answer.